Hello guys, welcome back to the channel. In this video we go back to the Databricks tutorials. We are going to see how to manage data with Delta Lake. We are going to use DDL statements to create and copy tables, compress files, check transaction logs, restore previous table versions, and select data from previous versions. Let's see the definition of a Delta Lake, and then we are going to proceed with the practical examples as we always do. Manage data with Delta Lake. Delta Lake is an open source project that enables building a data lakehouse on top of existing cloud storage. The purpose was faster queries on large datasets. The key features of a data lake is it's open source, it is optimized for cloud object storage, it is scalable, and it couples compute and storage to provide optimized performance regardless of the amount of data. It also supports ACID transactions. ACID stands for atomicity. That means all transactions either succeed or fail. Stands for consistency, that it guarantees how a given state of the data is observed by simultaneous operations. It stands for isolation. It refers to how simultaneous operations conflict with each other. And for durability, which means that committed changes are permanent. So let's get started with the practical examples. The first thing that we have to do here is create some dummy data. We are going to create a delta table called people123, select whatever name you want, using the create or replace table command. For the columns, we use ID, first name, middle name, last name, gender, birth date, SSN, and salary. The data does not really matter here. It is just dummy data. It is an example. So let's run this command and create a delta table and insert those dummy values here. So we are going to insert 3 records. And then let's select, as you can see, it affected number of affected rows equals 1, number of inserted rows equals 1, and then we can select from this delta table and you will be able to see the data. Yeah, as you can see, 3 records, right? You can also go into catalog in your default schema and see your table, people 1, 2, 3. You can select sample data and you will see the data here as well. So let's go back to our workspace and let's see how we can actually clone the data. There are 2 types of cloning when it comes to Delta Lake tables. We have the shallow clone and the deep clone. The shallow clone only duplicates the Delta transaction logs of the table being cloned. The data files of the table itself are not copied. Shallow clones just copy the Delta transaction logs, meaning that the data doesn't really move. So these clones are cheaper but depend on the source. If the files in the source are removed using the vacuum command, the shallow clone may become unusable. Therefore, shallow clones are typically for testing and development. On the other hand, a deep clone makes a full copy of the metadata and data files of the table being cloned. It does not depend on the original data. So let's demonstrate that by actually using a deep clone command here. We can use create or replace table. Let's call this deep clone people, and the command is deep clone and the delta table that we created above here. So let me run this command and see what we get. Perfect. Now, as you can see, the source table size is this one, right? And the copied file's size is exactly the same as the source table size because we actually copied the transaction logs and the data itself. So we can select from this table and we will be able to see the data. Now, if we run the shallow clone command here, which is very similar, instead of deep, you use shallow clone and you clone the people table. And if we do that, you will see let it run, and you will see here that the copied file size equals 0, meaning we didn't actually copy the data itself, only the transaction logs. And you can witness that by going into catalog, browse your DBFS, and you can see here we have the deep clone people, and you can see we have the data, the parquet files here, and the delta log, right? So we have the data and the transaction logs. But if you go into the shallow clone table, you can see we only have the delta logs, right? And we actually point to the source table. That's about it about cloning. So if you want to, if you are developing new stuff, just use shallow clone. It is cheaper. And yeah, that's about it. So let's move on to overwriting a table. There are multiple benefits to overwriting tables. Speed. Overwriting a table is much faster than deleting data. The old version of the table still exists, so we can time travel to older versions. And concurrent queries can still read the table while you are deleting the table. You can use create or replace table to replace the contents of a table each time they execute. So exactly, again, we are going to create a new table called person, same columns and similar data. So let me run this command, create this person table. And then let's say we want to create a new table, and we are going to select all the table here from person, right? And call this person test. So a new delta table called person test. And then we can actually describe, let's describe here the history and see what we get. As you can see, we selected this create or replace table operation, and you can see the history, and you can see the operation metrics, number of files, number of output rows, number of output bytes, etc., etc. It is very cool that we can overwrite the table, and it is faster than delete, as we said. And of course, we can time travel to older versions of the table. So it's pretty convenient if you ask me. Then we have insert override, which is a very similar command with the difference that it will fail if we try to change our schema. For example, now if we select everything from person and insert override the data into person test, and it's going to override the data. Simple as that. And you can also describe history and see what operations we performed. Here is a write operation because we used insert override, right? So this is a write operation. But if we select star from person and we add a timestamp column, it's going to fail because the schema is not the same. There is a schema mismatch detected when writing to the delta table. Then we have insert into, which is the typical append operation when you want to append new rows to an existing delta table. This allows for incremental updates to existing tables. We are going to insert into exactly the same data into person test. So in theory, we should have duplicated data. Yes, we do. Perfect. And if you describe the history, you will see that this is a write operation again because we insert data. Moving on, we have the merge operation. So the cool thing about Delta Lake is that it supports inserts, updates, and deletes using merge statement. As we all know, the merge statement is probably the most significant operation that we use as data engineers, right? So we merge into the target table using the source table on the merge condition that we are going to define, and when the data matches, then we do what we want, and when the data does not match, then we do something else. So let's create a temporary table called table updates with the same schema and similar values. Some values have the same ID with the data that we inserted in the original table. And let's select the data from this table, from this temporary table. As you can see, we have 4 records, and we can perform a merge statement, merge into person, using the table updates on ID. We are going to check based on ID, and when matched, when the IDs match, and the salary is null, but the salary in the table updates is not null, then we are going to update the salary. When not matched, then insert star, so insert everything. Let's run this command, and we should be able to perform the merge action here, a merge operation, and select the data from person. And that would have all the data here, the merge data, right? Perfect. That's how you can use the merge operation in Delta Lakes. Let's move on to the next cell. Here we create a similar table again called people 789, etc., same columns. And we are going to initially to insert these values and then insert those values, perform an update and update the salary when middle name T includes T here, and delete from people where salary equals that, and perform a merge statement as well with those conditions. Nothing fancy, but let's run this here. And the cool thing about describing history is that you can see all the operations that have been taken place on this table, which is very, very important because you can see the history, what happened, the number of records written or deleted. So you can see everything here. You can see the versions. Every time that we perform an operation, we get a new version. So as you can see here, we have 8 versions. 0 that we created the table. Then we have a write operation for the next versions here. We appended data, right? And then we performed an update, and then we performed a delete, and then we performed a merge. So you can see all this, the history here, also as other properties, operation metrics, the number target rows copied, etc. You can see a lot of things that they are very, very useful when you want to check the history of that table. And you can also restore to a past version, to an older version, but you can also select data from a specific version. Let's list all the files of this table on dbfs. As you can see, I run this command dbutils fs.ls, and this is the dbfs path for the table. We have the parquet files that contain the data, and we have the delta log that contains the transactions. Records in Delta Lake tables are stored as data in parquet files. Transactions to Delta Lake tables are recorded in the Delta log folder. Now, if you list all the files in the Delta log folder here, you will see that it has .crc file, .json files, and here, if you query, for example, this JSON file, you will see let's do that actually. And let's query this file here, JSON number 5 from the Delta log. And you will see that it has the add column here where it says what new data was added. Here, data change is true, and it has all this information here about the new data. And then you also have the remove column, which displays which column was removed. The add column contains a list of all the new files written to our table. The remove column indicates those files that no longer should be included in our table. When we query a Delta Lake table, the query engine uses the transaction logs to resolve all the files that are valid in the current version and ignores all the other data files. Then we have compacting small files and indexing for improved performance. Files will be combined toward an optimal size by using the optimize command. Optimize will replace existing data files by combining records and rewriting their results. We can add the z-order indexing to combine similar values within data files. So if you run this command, optimize the table name z-order by ID to combine similar values based on the ID, and it's going to combine small files into larger files. As you can see in the metrics, it says number of files added equals 1 and number of files removed equals 6. So we combine smaller files into a larger file to optimize performance. And if you run the history command, you will see that the operation is optimized here, right? Next, we have rollback versions, how to select data from older versions or how to restore an older version of the table. Let's delete the table. Let's delete the data from the table. Let's select now everything star from the table. You see it's empty, query returned no result, but we can still time travel and select data from past versions. So if we select star from people 789 version as of 5, and this will give us the data as it was in version 5. How cool is that? I mean, you can time travel, which is perfect. And you can also restore the table as of version 6. So you can restore the table to whichever version you want, right? And if you run the describe history command, you will see now the operation, the restore operation as well. You can see we deleted the table and then we restored the table. So you are not off the hook if you delete data or if you drop a table, because actually someone can see the history of this table and see the operations that have been performed. Even if you have restored the table or reverted back to a different to an older version, someone can see the history and, well, I mean, there is nothing, there is no place to hide actually. Finally, we have how to remove stale files. If you wish to manually purge all data files, this can be performed with the vacuum operation. Vacuum will prevent you from deleting files less than 7 years old. If you run the vacuum command on the Delta table, you are going to lose the ability to time travel back to an older version than the specified data retention period. You can use the dry run version of vacuum command to print out all the records to be deleted. 0 hours means to keep only the current version. If you want to vacuum for and retain 0 hours, meaning that you are going to keep only the current version, by default, it's not allowed. So you have to use to disable this configuration here, which is the retention duration check dot enabled, and that should be set to false, and the logging enabled should be set to true. And the dry run command is not, as we said, it's not going to delete the data, it's going to show you what data would be deleted if you don't use the dry run command. So let me do that and see what we are going to delete. Okay, so we are going to delete these 5 records, right? Now, if we display and we list all the files of this table, as you can see now, we have 10 records, right? Now, if we vacuum and retain all the current version, so we can use that, we can do that by using retain 0 hours and only keep the current version of the data. So it's going to delete these 5 records that we displayed up here, right? And then we are going to run the same command and see if we actually deleted those 5 records. Okay, so let's see what we get now. From 10 records, we should have less records now, right? Yep, we have 5 records because we deleted the records here that we displayed using the dry run command, and we kept only the current version of the data, which is good. However, so we have more space now, but we cannot time travel. So make sure that you know what you are doing when you use the vacuum command. This is it for today, guys. This is how you can manage data in Delta Lakes. I hope you enjoyed the video and you learned something new. I'm going to upload the notebook on GitHub so you can practice along when you have time. Thank you for watching. Please leave a comment, click the like button and subscribe to the channel, and I will see you in the next one.